Hello. Welcome to the Cross Labs podcast On My Mind, where every week Cross Labs members and friends share a little bit about, well, what's on their minds. We're scientists and researchers who think deeply about what intelligence, life, technology are, but also what they could be. And with today's extremely fast rate of algorithm development, we certainly do have a lot on our minds. So sit back, relax, and enjoy the conversation. For today's episode of On My Mind, Tanner has something really interesting on his mind, and that has to do with AI models that either communicate with each other or chat with each other or interact with each other in some particular way to form a community of models.
This is something that's on my mind, not something I have good answers for. How can we create an interacting community of LLMs, right, large language models, but this could be extended to other AI models in general.
It seems like half of my emails seem to be auto-generated these days. Google has this really great suggestion while I'm writing, and all you have to do is swipe in order to autofill the suggestion. And at this point, because I've used it so much, it does a pretty good job of getting a good gist of how I write. So I would say probably half of my email content is auto-generated. And I can't help but wonder, it going to be the full thing is auto-generated and everybody's using something like that. So it's just ChatGPT talking with each other over and over again.
I think the question that comes up in doing this kind of thing in practice is you have to answer why is having two models separate better than just having one bigger model that does what both of the two models do. Because like with humans, you can't basically fuse two people's brain together and make one person, but with neural networks, there's no reason why you can't actually just train everything together end to end. Using this sort of metaphor of communication, they have to have something where by splitting what they're doing into two parts, that's somehow better than having the one integrated thing. So you could even take one GPT model and give them different contexts, but have it be the exact same model and they would behave differently. But at the end of the day, the tricky thing about it is it's all information processing and they kind of have access to the same information. In information theory sense, when you measure the mutual information between two variables, you assume this kind of perfect inference engine that would be able to say what the probability distribution of the other variable would be given seeing the one, and a neural network is just, by supervised learning, is just learning to approximate that. So the tricky thing is that when you actually split the network, if both sides of the split are getting the same information, then mathematically there is no advantage for them to talk to each other.
This is actually quite related to one of the ideas that I suggested in the chat, is that we started to talk about communication between the AI agents and we directly jumped to human communication. And so the idea that I suggested is, why would AI communities basically need human language and not another kind of protocol or another more appropriate, more optimized protocol? Human language isn't perfect by definition, and there is this kind of bottleneck where we can't explain fully what we mean. So is there another kind of language or protocol that these communities might develop to better understand each other?
When we have different models doing similar tasks, so I would think of if we have a fleet of Tesla cars trying to negotiate an intersection, I bet they must have even today a system where they can talk to each other. But if I have a Tesla and then a Waymo car, how is it that there is no protocol today for them to talk to each other? And the default solution is just to mimic human behavior, which is crazy inefficient. And I think that would be like a cooler way to talk or to see communication between agents.
In the case of traffic, they also need to be able to negotiate with human agents, and I wonder if that's a limiting factor.
For the moment, there are still humans behind the wheels, but in the future, if every car is controlled by an AI, then you don't really need to interact with humans anymore. It's just cars interacting with other cars. Once there's no human on the road, only AI, then what's the point of having human language?
I mean, it really does feel like common ground. With common ground, you've got an understanding of your role and the other people's or agents' roles, roughly speaking, and the rough space of where things are. And the thing with common ground is it does break down, and we have mechanisms repairing it. It's a thing we see with people in traffic, and that's one of the reasons why I think it's interesting to ask what traffic management might be like when you no longer have people. We've all got similar but not identical goals when we're on the road. We want to get to destinations safely, but not the same destination, with various weights for speed and all of these other things. But we establish common ground through this existing framework of traffic rules, but not specifically those. It's, I'm going to tail this guy, but I'm going to tail him at a certain distance so it doesn't bother him. Or you might flick lights to warn that, I don't know, there's a cop coming the other way. But we have this activity of establishing that we're on the same page, right? We have the common ground. There is an interesting question here, right? Which is, how do adversarial models talk to each other?
You wire them up and you treat them like one giant brain, but then you just have some of the weights move in a direction to achieve one thing and other weights move in a direction to achieve another thing. That's the trick, is you can back propagate through neural networks even when you stick them together.
Looking from an engineering problem point of view, though, I've been wondering about what would be some interesting combinations of different models.
And so there's certainly a lot of things where you use different modalities together. And in practice, that ends up meaning that you're using multiple different models because people independently are creating these models. So the depth to image version of Stable Diffusion, it uses another network to take an image and generate a depth map, which is then used to generate the training data for Stable Diffusion. So like that's one situation where like you don't want to have, or you can't in practice have someone hand label 5 billion images with depth fields, with depth data.
Right. And of course, there's a distinction between generation and compression, right? That sometimes folks confuse. Some of the trusting GPT when you shouldn't comes from that, right? It's not a compressed set of all of the information it's read. It's able to extrapolate into things it thinks should be part of the distribution. And those are different use cases.
Another thought that had occurred to me is this idea that I read about a few years ago. I can't remember who wrote about it, but they were saying that general AI was just around the corner because it's only a matter of stitching together all of these specialized models. And once you have all these specialized models that can process sight, can process audio, can process writing, and can generate all these different things, they would just need to be able to talk together in some certain way, and then you have general AI. And I can't help but thinking about kind of how I see myself a little bit, especially if I'm thinking about myself as a machine. I have all of these different models that my senses are using in order to process the world around me. So I have my eyes, they're physical objects. They have a function that processes visual. Same with my ears, they process audio. And then I also have all of these internal organs that have their own functions, and they're all stitched together in my brain somehow. And there's even additional models in my brain to process these input in terms of an emotional level, or all these different ways of processing this information. So I can't help but wonder if that's another application of having a bunch of models talk to each other, is towards this goal of this quote unquote general AI idea.
We're a composition of models, or are we one model with different peripherals? I would lean more towards what you described, but there's an argument to be made the other way as well, all connected into the same nervous system. So the line does eventually get a little bit blurred.
Even a single model has different parts, right? You can have a ConvNet that then also has some attention layers, some dense layers. They do different things on the information flow. It's one flow, multiple parts, and they co-adapt.
And I think another thing that we haven't yet talked about with regards to one large model versus lots of little models stitched together is our very bad track record of coming up with models that have all of these biases in them and can be really harmful to people who aren't in the majority of the data that these models have been trained on. For example, a lot of the models that are out there today have a lot of rightfully deserved criticism that, hey, these were trained on data that represents a large part of the population, but it leaves out a whole bunch of people who aren't necessarily in the majority. And it's very harmful. It has very real impact on those minority groups. So,
The little models are just as bad. So it doesn't really solve it to split it up.
I also would like to add, the other day I read that in China, they are now restricting the access to ChatGPT because they say the model is Western propaganda. To the point of the biases in the training data, it is absolutely correct. I'm pretty sure most of the literature that OpenAI had to train an opinion about whatever happened in China comes from Western media, or at least Western language. I'm pretty sure they didn't train 50-50 with Chinese written literature on whatever happens in any country. So of course it's going to be biased towards an opinion that we could say is westernized, but that doesn't mean that the AI is intentionally anti-anyone, I assume. I think that was what I was questioning somewhere in the first episode, was if transformers are not the thing that can answer our questions for, for real, to say it in a way, as in, transformers are like confidently wrong and all this stuff. How could we train something that can wait, what I'm saying is accurate, these are my sources, like the regular scientific method? What's the next architecture that is going to take us across the line for that?
I mean, I think the focus on citing sources is better than trying to make something that gives you the actual truth, because whether a statement is true or false is not a property of the statement itself. But on the other hand, if, for instance, you have a model that the only way it can communicate to the reader is to highlight sections of a document that is provided to it, then that has a different degree of verifiability than a model that interacts by fabricating language.
It's a search engine.
Yeah, it's a semantic search engine. I mean, this is literally the kind of architecture people did on question answering before GPT and the like, is instead of having it generate the language, they had data sets where you had a reading comprehension kind of question set. You have 4 paragraphs to read and a question, and you have to highlight the sentence in the 4 paragraphs that answers the question. And that was an architectural paradigm people used.
I mean, why isn't that successful?
It's boring.
Yeah, it's not sexy. It's like, yeah.
But wait,
People don't, like, people might think they want ChatGPT to be a search engine, but they want like some crazy AI that's going to spew all sorts of random stuff at them when they talk to it. Like that's what's exciting about ChatGPT, not that it's telling you true things.
yeah, I mean, maybe for a while, but if this question answering thing, if that would have read basically almost everything that's ever been put on the internet, then
No, of course, it's reading a specific document. If you ask it to underline everything on the internet, that's way outside of scope.
You know, that reminded me a bit of Last Week Tonight, where this guy was saying like, oh yeah, one of the big problems now with AI is the black box problem. What do you think about that?
Yeah, I feel like there should be some Shakespearean quote about whether or not we ever know each other or something like that. Humans don't know how other humans work. So, like, yes, there's also a black box problem when you hire someone to do a job, or when you have a coworker, or when you ask a doctor to help you. You don't know how they're really making their decisions, and they can make up some kind of explanation. Generally speaking, the explanations made by humans are as often post hoc as they are actual indicative of the thought process that led somewhere. Because obviously humans implicitly know the exact source of everything that they ever say and can cite it accurately without just making up sources. We're post hoc reconstructing. And of course, they have the ability to directly infer whether a statement is true, independent of context. That's definitely human abilities here.
yeah, but I mean, this whole black box thing, I don't think it's entirely unjustified, because there's definitely applications where you kind of want this explanation. You don't want this black box feature. And then maybe that just means for those applications, we shouldn't use neural networks.
Or it goes back to citing sources like we talked about before.
Yeah.
Yeah, I would just say, I think it's also important to be critical to say, why are we insisting on an explanation? What are we actually going to do with it? Are we just using that explanation to kind of mimic a human heuristic where if someone can explain something, we feel more confident that they know what they're talking about, which wouldn't be true for an AI, right? Like that's the danger of it, that you can make AIs that pretend to explain things and it will convince people to trust it more, even when the explanation is just complete bullshit.
Let's say you use what's an example actually? Where do they complain about this black box stuff? When
medical decisions, legal decisions.
Yeah, exactly. So legal decisions, you ask the neural network, is this person guilty or not? And then it says yes. And that's all it tells you. That's not a valid use case for neural networks. Like, no. And it will never be. You will have to argue why. You should argue why this person is guilty.
But then, wouldn't we arrive to a problem at some point that I'm pretty sure, I have no idea if it is now, but AI at some point should be able to solve stuff that are like far beyond our comprehension. If we limit ourselves to, you just explain this black box, then won't we become the limiting factor in intelligence?
I mean, that's also an issue, but I think the more realistic thing is we'll just make bullshit engines that are very, very good bullshit engines that are so good we can't even detect that it's bullshit. Because at the end of the day, that's what human explanations are.
No, I mean, sometimes, yeah, a lot of the time maybe, but we have to not do this, prevent it. Especially if we use AI to actually take legal decisions, then we just have to definitely prevent it from...
So, what I would say is that for the case of legal decisions, the important thing is not an explanation of why the model output a verdict of guilty. That's the wrong question to ask. The right question to ask the model is, what things in the law did this person violate? And I know they sound very similar, but it's actually a very subtle difference, because the AI can use any thought process to decide this clause is relevant to why this person is guilty. But at the end of the day, because it's only highlighting clauses, it's checkable. And it's checkable in a way that is independent about whether it sort of explains its thought process but like accurately, but in a way that's unhelpful, right? Because you're setting a standard. It's not that you're setting like, I need the judge to impress me with how smart they are and how well they know the law. You're saying like, at the end of the day, it doesn't matter how smart the judge is. The only way that they're actually allowed to reach a conclusion is by this very formulaic thing of citing which things were violated and then getting a confirmation from a third party that in fact those things were violated.
Yeah, totally.
So it's different than an explanation is what I'm saying. It's different than a white box because it's not about the judge's brain in that case. It's actually about the legal code.
Yeah, I would argue it's more of a, you want your AIs to be co-agents or fellow team members rather than tools. That's not necessarily a discrete category. But when I encounter things that are supposed to be more automated in the tech space, in the software world, the problem people run into isn't so much that it's a black box, it's that it's a black box that doesn't play ball with them. It does things by its own rules. It's not a member of the team.
Yeah, I mean, I would say like, there's a lot of social reasons why we explain things to each other and a lot of practical reasons. But the thing that is important is replicating the functionality or the utility that those actions have when humans take it, rather than chasing some goal of like the true reason why the thing did what it did. So like sometimes when we explain things, we're doing it to teach. And that is important, right? Having an AI that could teach someone else to do what it does, including like a human, that would be really useful. Independent of whether it's necessary, we would get use out of it. So it's worth searching for. But the trick is the way that you explain something to teach it may not be the actual way that you're following internally when you actually are doing the thing.
Yes, the curse of expertise is well known for that, where you skip steps and you may not even know all the steps that you're doing. So even if you try to describe them all, you're going to miss some.
Yeah, I mean, like a more generous way of putting it would be that a lot of the time when we teach, we can't give someone an algorithm for thinking like us, but we can walk them down a path where we think that if we were to walk down that path, we would end up thinking like us.
So if I were to put that in a sentence, the problem is not that AI has this black box, it's just that the box is not the same color we're used to, kind of.
Yeah, I would just say we have unreasonable expectations of our technology. And also we have unreasonable kind of beliefs about ourselves and each other. You know, because we make ourselves look better to our eye than we actually may be, then we transfer that as a strict requirement to technology when the actual solution that humans use doesn't fulfill that brief either. All right, who did we just lose?
I think we just lost Maddie. But I'm going to have to hop off too because my train's going to be here in 10 minutes.
What station are you? Oh, well, maybe we'll have to bleep this out, but what station are you at?
Kyoto Station.
Bleep.
Very high tech. Yeah.
That's it for this week's episode of the Cross Labs podcast On My Mind. Don't forget to like and subscribe so you'll be the first to know when the next episode is out. Thanks so much for tuning in, and we'll see you next week.